In this video, we look at a 1 to 4 line demultiplexer. The idea is we have a data line we wish to route to one of these possible output lines based on a two binary digit input. Now, in the case where the binary digits are both 0, the data value is routed to this. And you can see if it's 0, you get a 0. If it's a 1, you get a 1. So the value at this output represents the data line. If I go to 1, 0, 1, it routes it to this data line, and again you can see if I toggle it, the value at that line is dependent upon what the value of the input data line is. If I go to 1, 0, like that, it routes it to the third line, and again you can see it's toggling back and forth based on the value of the data line. If they go to 1, 1, it drops to the final one, and again it's toggling. Now, this is the first case where we've used 3 input ANDs. Normally we've just had 2 inputs on the ANDs, but here we have 3. And we have 3 inputs onto an AND gate. It means that the output will be true if all 3 are true. If any one of them isn't true, the output will be false. A 3-input AND, which we see down here, is basically the same as 2 ANDs joined together. So in the case of the 3 input, you can see it's only when I get all 3 of them lit that the output goes to 1. Similarly, if I've got 2 of them ganged together, it only goes to 1 when all 3 inputs have gone to 1. So this must be 1, and this must be 1, and this is only 1 when these 2 are 1. So the 3-input input AND is the equivalent of 2 ANDs, but it's much simpler to draw. Now the situation, how does it actually work? Let's go back to zeros here. When we've got zeros, it's again similar to the previous one. The zeros coming through the inverter here, the NOT gate, and that becomes a 1. It becomes a 1 here. So that means this AND is ready to fire. So if this value is a 0, nothing happens. If it's a 1, you do get a fire. So the value at this pin here is going to represent this value when these are zeros. Likewise, when I go to 1, 0, like this, the 1 input here, of course, well, it's going to turn this one off. So this one no longer will fire. It doesn't matter what the value of the input is because the inverter has inverted the second input to 0, and the AND will not fire. This one, however, will fire because the 0 input here inverts to a 1. The 1 input here makes it capable of firing, and the data value is the final element, and turning off and on the data value will, the data value is represented at this output pin. Likewise, for the third one here, when we have the situation like this, 1, 0 in our input, what we have is this line here is coming in as 1. This line here, the 0 line from the input comes down here as 0, is inverted, it becomes a 1. So the only thing that's missing is the value of the data value, and when it's 1, the output pin will be 1, and when it's 0, the output will be 0. Likewise, when you have both of them turned on, both of the address lines, I guess that's what they really are, they're telling us which address to send the data to. When they're both on, well, there's a 1 there, there's a 1 there. All these guys, of course, are forbidden. That inverts it, so you get a 0 there. That inverts it, so you get a 0 there. These are both inverted, so you get zeros there. So these 3 gates cannot fire. This is the only one that can fire, and it will fire depending upon the value of the data value. So what we're basically doing is we're addressing which of these 3 lines to send the data to.